Ooh, I'm jumping. Good morning, everybody. I want to start out by telling you a story. It had to do with a friend who had a boat years ago. And he wanted to put a compass on his boat. So wondering if anybody knows how compasses work, but compasses actually work because they can sense magnetism. And we've been talking about magnetism, and the Earth has magnetic fields. I don't know if you like the shirt or not. No, Mr. Fosnight likes it. Earth has magnetic fields, and so we can use compasses to find our way around. When I used to fish on Lake Erie, there were times when I needed a compass. One time we had gone out early in the morning, and a fog rolled in after we were out, and we needed to use a compass to get back to shore because you couldn't see in any direction. You had no idea where you're going. And so to be able to navigate with a compass, believe it or not, is really sometimes necessary. Hey, Brianna. So it's cool to be able to use a compass. It's not necessarily that easy, and a lot of people haven't figured it out. But so I've used it, especially on my boat, and I've used one when we're in the woods, in state park or whatever. If I suddenly feel like I'm not sure which direction I'm going, sometimes the sun will help you navigate because you know where the sun should be in the sky. You should, right? And if it's a cloudy day, if all those things happen, sometimes you don't know where you are. But boaters usually had a compass on their boat. Well, I had one friend that put a compass on his boat, and it did not ever seem to work properly. Hey, Brandon. And so he couldn't figure out why. Why isn't this compass working? Why isn't it working? Why isn't it working? And what we actually discovered is that where he had put the compass, right beneath it, and the plastic was only very thin plastic, was a harness of wires, just a whole group of electrical wires flowing through. Okay, so you have all these electrical wires and you have a compass above it, and electricity can create its own magnetic field, and it was interfering with the compass. And so the compass wasn't functioning properly. That's the first time I ever heard that. And all he had to do was move it to a different location and it worked fine. And so, yeah, that was a lesson learned, but it also is kind of cool because you understand that relationship between electricity and magnetism. One of the cool things, and I'm just going to talk a little bit this morning, one of the cool things that about our Earth is the magnetic fields. And I just was reading in the news that our magnetic field is actually, it's moving, it's been moving. True north is slightly off, and it really has more to do with what's going on in the interior and the center of the Earth than anything else, and really is having to be adjusted. And so when scientists are looking at the magnetic north, and here's the North Pole, and the magnetic north has, now the North Pole is the axis, the invisible axis which the Earth is spinning on, and the magnetic North Pole has been just moving and moving away from that, and to a point where it's measurable. They measure it considerably, and they said it's moving faster than it ever has. One has to ask why. Now, we can't get into the center of the Earth and know exactly what's going on in there. We can only make assumptions about what we think is happening. But there are changes going on. But magnetism is really all around us. One thing I wanted to point out is magnets will work both ways. Not only will magnets attract a metal to it or another magnet to it, I've shown you that, but magnets will also be attracted to a metal, so the metal itself can act as the attracting force, okay, and draw something up to it that has, oops, let me get it up a little farther, that has a magnetic quality. That's a little less than an inch, okay? And I can't get this to come off. I'm gonna keep it away from my phone. I'll break another phone. Let's try it this way where you might be able to see it better. About a half inch, it's able to draw it in. A magnet with another magnet, it's probably a little bit different of a distance. Maybe not, just ever so slightly. Some of those things aren't measurable. But magnetism and electricity really go hand in hand. And remember, we were talking Tuesday about generators. I have a generator in my garage, and that needs to be repaired. The motor does. But when that motor is functioning, all it's doing is spinning magnets in close proximity to a bunch of wires, and it is generating electricity by doing so. So even though it seems complicated, it actually is rather simple. Again, one of the sad things about us being apart is we don't get to do some of the things that we have done at school. We get to create little motors. We've created little motors in the past and done some really neat stuff. It would be really cool, and I've been thinking about this for a couple of years, but it would be really cool to have attempted to create a generator of some sort. For some reason, I can picture a couple students maybe on a bicycle or similar device, maybe a hand pedal or something, trying to make electricity. I know Mr. Fosnate's probably laughing, thinking about who he'd want to put on that. Ahead of class, we would probably discuss that and say, if so-and-so's here today, they're going to be our guinea pig. we're going to put them, see how much electricity they can produce, and we'll measure it. We'll measure it with a meter and see who's the best at it. I think Brianna would be pretty good at it. And there's a few other people that I think they would probably love to do it. But anyways, the big thing there is that relationship between magnetism and electricity. They're very closely entwined and very. If she was awake, well, if that's the criteria, we could put Imir in that category too. So, all right, so that's so funny. Anyways, what I really wanted to do today is talk about the fact that this is going to be our last class, and we need to make sure we have everything wrapped up. Packets need to be in. Today is the 21st. Our grades need to be in next week. And so I would like to have everything as soon as I'm looking at my calendar. It's literally a week. This is a holiday weekend. So that only gives me a couple days to grade every 3 grades worth of stuff. If you haven't submitted stuff, I've already started to grade things, of course, as they're coming in. Packets need to be turned in to the school. Online stuff, make sure you're submitting it, and we'll get a conglomerate of a grade. Sometimes I don't always put a grade in Google Classroom, even though you've submitted something. I don't necessarily put a grade on it, but I do put it in the grade book. So it'll reflect in your final grades. So don't panic if you see something that you submitted and there's no grade for it yet. I don't always grade those things because it's just, I mean, I grade the assignment. I don't always put a grade in Google Classroom because it's just adding steps for me, unnecessary steps in my view. Great projects being turned in. I'm having fun watching some of your guys' stuff. So good job on that, and keep plugging away. Get it done. I know some of you are just going to wait till the last minute. Don't try to turn something in next Friday. I have to have my grades turned in next Friday. Just because it's the last day of school. Don't do it. I got to have everything turned in. Please get it turned in a few days before that, so I have time to grade it and get it in the book. If you try to turn it in late, it's going to be closed out, and I can't go in and change it. So this is a weird way to end our school year. We didn't get to do any field trips. We're not going to get to do our derby, which really makes me sad. That's become Mr. Fosnight and I's favorite thing to do. We would be in class right now. I might be standing up there teaching you something while you guys are working on your cars, and we might be talking about friction resistance. While we're talking about that, let's talk about how lubricating things. Let's talk about cars, since we're talking about derby cars. Help actually not only help keep parts from wearing out, but and reduce friction. But there's instances where it can prevent things. Inside the wheels, you have the wheels on a car. Let's say you have 2 wheels on a car, and basically those wheels ride on a shaft there, And for this wheel to be connected to that shaft, there's what's called ball bearings in there and lubricant. These things wear out. They really do over time. I have a really old truck. Some of you may have seen it, that started making horrible noises. And I thought, oh my gosh, what's going on? Is it falling apart? Am I going to die? And it turns out that one of those bearings had gotten bad. They wear out. And so when parts start wearing out, instead of being a good solid fit and it's spinning correctly, all of a sudden it's wobbly and it doesn't want to spin correctly. You can have what you call, well, the sun's coming out for a minute, catastrophic failure, where the car literally, the wheel could fall off, the car won't want to go. So there's lubrication is really cool in that it provides protection by reducing that friction. In our little cars that we make for the Derby, we don't put grease in there, but we put a dry lubricant, which is just graphite. I'm kind of questioning myself. Graphite, and it's dry. It's not wet like we think about oil that we put in a car or something. And so it's important to understand that something dry like that can actually be a lubricant too. And we have to kind of think of outside the box on things like that. So something that's dry, that's not a liquid, but is not in a solid clump, it's been pulverized into a powder, it can be very effective as a lubricant. Another example of that would be like talcum powder. Talc is basically a rock, and it's been grinded down into a powder. We can use it. It's very slippery. When we touch it, we could use that as a lubricant too. Believe it or not, there was occasions when I was performing live that it was so hot and sweaty that I actually would put some on my fingers so that I could keep my fingers moving up and down the guitar. And then of course I'd have to clean it up afterwards, but it actually does work. There's another one that everybody should know about: pizza. When you have a big clump of dough, when you have a clump of dough like this and you're trying to stretch it out, make it into a big 12-inch pizza or 16-inch pizza, and you put a little flour on your hands. Why? So it doesn't stick to your hands. Well, what you're trying to do is reduce friction. And you put a little bit on the table so it doesn't stick to the table. In pizza shops, they usually have a stainless steel counter. Well, that dough will stick to that counter. They need to put a little flour down there so they can stretch that out. Some places throw them up in the air. I've worked at places that we learned how to throw them, just like in the old days, right? Throwing that pizza dough. What we're doing is we're reducing friction. We don't want it to stick. There's a lot of instances where what we're talking about and what we've been teaching you in class, we can use every single day when we do stuff. It's that simple. And it'll help prevent things from wearing out. So think about that when you're riding your bike, your skateboard, anything like that, anything that has wheels, anything where you have one surface against another surface. If you're trying to move, something that's really, really heavy, if you don't have those little floor gliders that they sell now, boy, what a difference that makes in moving stuff on carpet and stuff. They reduce friction. You can use cardboard. I've slid things that were really heavy. I slipped a piece of cardboard under them and slid them on that. Saves my back, reduces friction, makes it easier for you to do something. We've, as humans, we found a lot of ways to overcome friction. All right. The people that are on here, I don't know. I don't expect you guys to have any questions. If you do, speak now or forever hold your peace. I hope you guys have a wonderful summer. I miss you already, and really, really hope maybe I'll run into you somewhere over the summer. And some teachers don't want to run into their students anywhere. I do. I'd love to see you guys over the summer, and I've seen people in the grocery store or various other places. One year I saw a student at the county elections board. He was with his dad going in to vote, and I was going in to vote too. So you never know where you're going to run into somebody. And I hope you guys have a wonderful, wonderful, wonderful summer. And if you have any questions, like I said, we still got a week. Don't hesitate to call. Don't hesitate. Well, you can't call me. Don't hesitate to text me. Thank you, Brandon. Don't hesitate to send me a message. Let me say that right, in Google Classroom, or email me. You got my email address right there in the live chat. I have responded to a lot of people. So don't not do it. I miss you, Krabby. Miss you, Brandon. Anybody else that's on there? Ciao. Peace out. Love you all. Have a good summer. This is the last broadcast. Nothing next week. Next week, we're going to spend time cleaning up and getting stuff graded and cleaning the classroom out. Yeah, we still got to go back and do that. So, all right, take care, everybody.